The next basic sensing element is the thermistor. And like the transistor and thyristor and so on, it has this istor part in its name, which shows that it's a semiconductor-based element. And the therm, of course, shows that it's a thermal element again. And just like for the RTDs, PT100, the resistivity changes as a function of temperature. So it's basically the same as an RTD, but with a bit different properties. They are very nonlinear. Remember that the PT100, they are linear, quite linear, but these are non-linear. They have a limited range, typically -30 to +120 degrees, but of course I've seen a bit more, but not extremely extreme temperatures. So you have a limited range, but however, note that these temperatures, they are well within the range that we find in our everyday life. So if you want a thermometer for your living room, for a fever thermometer, for the temperature mainly outside, will be within -30 and plus some 50-60 degrees maybe at worst. So for everyday purposes, the range here is far beyond good enough. But you can't use it, for example, in your cooking oven or something like that. There are two versions, the NTC and the PTC, where the NTC has a negative temperature coefficient, and it's shown here. The resistance drops as a function of temperature. Note that the PT100 has a rather linear, but it has a rise in resistance as the temperature goes up. So temperature resistance here. That was the PT100. But for the NTC, the resistance drops with an increase in temperature. You also have something called a PTC, which has a positive temperature coefficient. But it's only positive for a certain short range, so it's extremely nonlinear. So this one is not as common as the NTC by far. It is used, however, as a thermal switch, for example, and the thermal fuse, something that turns off when the temperature becomes too hot, for example, to stop a motor that becomes overheated. Poor accuracy, well, that used to be true, up to 7% accuracy, but that is for older NTCs. The accuracy has increased very, very much, so they are now close to as accurate as the PT100s. So, on the good side, they are mass-produced. The cost is close to nothing, so they are really, really inexpensive. So for mass-produced purposes, they are really, really common. The accuracy is now good enough, so drop the poor. That was for the old version. So if you have an old thermistor in your drawer, you should really replace it with a new one. And the accuracy now is good. The cost is low. The non-linearity can be a problem in some applications. And the limited range can be a problem in some applications. But I guess among all the thermal sensors that we have, that I myself have, I guess the NTC is the most common one in all the sensors that I have in my car, in my living room, in my cell phone, and so on. So this is the most common one, definitely. The equation is rather rather complex, actually. look at this. This is the first one here is the resistance as a function of temperature. And you have e to the power of an a part, b, c, and d. And this is by nature, e to the power of x is a nonlinear function. But to make things worse, you add more nonlinearity to the function that was nonlinear from before. So it's you add more nonlinearity to the nonlinear function. And then you have, if you want to turn this equation around and solve it with respect to t, so the t becomes a, b, c, d, and ln squared, ln third. So it shows the nonlinearity of it. However, for modern NTCs, we have rather accurate values for A, B, C, D, and R ref. So we can find a very accurate equation for it, and reproducible equation, which means that we can, by using a calculator, for example an Arduino, we can easily calculate the correct temperature if we know the resistance. Also, the R ref is what you find in datasheets, is usually the resistance at 25 degrees. So if you buy, for example, a 2500 ohm NTC, that means that it has 2500 ohms at 25 degrees. Sorry. Remember the PT100? It has 100 ohms at 0 degrees, while the thermistors are usually specified for a temperature of 25 degrees.